Hey everybody, and welcome back to another video on my channel. So as you can see in this video today, I am starting in the third person template, and the reason for that is because I'm going to go over how to use functions within a motion matching table and go through explaining why certain things need to happen in order to make that work, right? So I'm pretty sure, with using GASP and seeing how their motion matching tables work, or maybe you've created your own motion matching chooser table that has a bunch of Boolean values or a bunch of like maybe floats, other stuff like that within your table, right? But then when you look back at the game animation sample project and you look at their motion matching table, you're probably wondering, like, how are they doing these functions? Like, how are they getting them set up and usable within the motion matching table? Everything that I've done, I just can't pick them in the chooser table. So that's what I'm going to show here in this video today by creating a few simple functions for us to use in a chooser table. So what I'm going to go ahead and do is I'm going to open up the content drawer, and what I first want to go into is let's go ahead and go into the animation blueprint, because there's not really anything we're going to be doing in the character blueprint, because a lot of the chooser table stuff, if you've seen my other videos, take reference or all the stuff from within the animation blueprint instead. So anything done in the character blueprint is not going to really matter unless we place them in the animation blueprint. So I'm going to go open up my character folder, and I'm going to go to mannequins, animations, and I'm going to open up ABP Mani, because this is where we have our main code at, or at least our main variables and other functions that are being run for just the basic state machine animations, right? So let me go ahead and dock that here. So now if we open this up, as you can see, what's going on is we're initializing the animation stuff up here with this event, and we're casting to character, which this node, when casting to character, is casting to the built-in default character actor that has been implemented by C++ into Unreal Engine by Epic Games developers. So if you ever want like a default character casting or anything like that, cast a character is perfect. Other than that, if you have a blueprint, like a character blueprint that you've been customizing, doing whatever with, then you want to switch it to that blueprint. So for example, in this instance, if I did anything in the third person template blueprint, character blueprint, then I would need to do a cast to BP third person character template here in order to get the character reference, get the proper character movement, and set everything up according to my BP. But for this video, I'm going to keep it on the cast to character just because I'm going to show you how to just make simple stuff with functions. However, you can tailor them to be as complex as you want them to be. So what I'm going to do is I'm going to take a look here at the stuff that we have going on right now, right? So one of the things you'll notice is we already start out and we're getting ground speed for our character, because what we're doing is we're getting our movement component that's been set as a variable here and getting our velocity. And for those of you that don't know what velocity is, in mathematical terms, velocity is your speed in a direction. So for example, if I say I'm going 50 miles per hour east, then my velocity is 50 miles per hour eastward. If I'm going 80 miles per hour north, then my velocity at that point would be 80 miles per hour northward. If you, hopefully, you're able to understand that, because that's what velocity is. So for example, if we go and click on this velocity, basically the X here is saying that, pretend like our speed is 500 centimeters per second. Well, the velocity here would mean that if we are going in the X direction, so left or right, at 500 centimeters per second, then that is our velocity, where it would be 500, 0, 0 if we were going 500 centimeters per second left or right. If we were to do 500 on the Y, that means we would be going forward or backward, depending on if it's a negative number, which I forgot to state for the X. But regardless, Y would be our back and forth. So if I'm going 500 centimeters per second on the Y, that means I'm going 500 centimeters per second forward, stuff like that. And then our Z is our up and down. So that would be 500 centimeters per second up or down, depending on what direction we're going. So that is essentially what velocity is, and that's why it's a vector in case we ever need to get like diagonal movements, stuff like that. So then what we're doing here is that we're then setting it into a variable so that way we can have it for use later with our essential movement data here. So in case you wanted to make other stuff with it. What we then do is we convert it, or basically like normalize it or get the length and return it into one float or number basically as far as our current speed. So, you know, on the X and Y, if we're going 500 X and 0 on the Y, it's just going to return 500 in just a forward direction regardless. Or if we're going left or right, 500 regardless, stuff like that. So that's why we have our ground speed set up. So it only puts together the X and the Y together to get the value of what speed we're going in a forward or maybe a strafe left and right motion. So the next part off the movement component, we're getting the current acceleration and checking to make sure that it does not equal 0 in any fashion. So if that's true, the next thing that we do is we get our ground speed that we set up here and we check to see if we are greater than 3 and see if that's true. And if both of these return true, then that indicates that this is true, which means that we are moving. And the reason that we have such a small number right here for ground speed is because the should move boolean is being used in the state machines, which, you know, what we're trying to do there is like on the smallest input, we don't want to trigger a full-blown walking animation. We still want to remain idle or do like the walk in place animation so we don't trigger full out like sprinting, running, full on walking animations, stuff like that. And then lastly, what we're doing is we're getting our is falling here. And at any point that we're in the air, we are technically quote unquote falling. And we set it here to be true if we're in the air at all. So these are the basic things in the animation blueprint that can help us. So if we were to make a chooser table, the only things that we can grab out of here would be our velocity, our ground speed, our should move, and our is falling. So as far as a basic chooser table goes, this is actually pretty solid. However, when it comes to placing animations in a pose search database, you may have a lot of other different, you know, kind of animations that, you know, not all jumping animations can encompass the is falling, or maybe not every, you know, walk, run, pivot, whatever should encompass a should move, right? So we have these as our basic setup for us to be able to then, you know, transition through the state machines in a simpler fashion, right? So in order to turn these into functions for, you know, our chooser table, this is what we're going to do and transition into, right? So what I'm going to do is I'm first going to grab these and I'm going to convert this into a function, or collapse into function, and I'm going to call it update references to have it as such. So that way we at least have our references updating, because believe it or not, these are pretty solid. It's just that for our current use for the chooser table, we might not want all of these. So what I'm going to show you now, because you pretty much have a basic understanding of how the set variables are captured in a chooser database, I'm going to show you now how you would do a function, right? So it's pretty simple as far as like what you already know or are familiar with. You're going to come over here to functions and you're going to hit the plus. And what we're going to do here is I'll start this one off with a is starting function. That's the first one we're going to make. I'm going to go over like very basic functions to create, similar to how the GASP makes their functions. However, I'm not going to go that complex because of what they're doing, how they're caching data, all the set variables that they have to offer and stuff like that. So off of the is starting variable, what we want to do first is we want to drag off and grab a return node, because this is absolutely necessary. Like, this is one of the necessary parts that we need to do in order to be able to call our function in a chooser table, because we have to be able to return the value into that table or the chooser table when we make it. So what I'm going to do first for the is starting is we're going to do something very simple or very basic, right? So what I'm going to do is I'm going to go back into update references real quick because there's something that we should make so that way we can call this appropriately. So I'm going to expand this middle section for the should move, and I'm going to move from the ground speed and the not equation or the operator here down a little bit, because what I want to do, or at least show you, is how useful current acceleration can be in certain situations. So what I'm going to do is I'm going to disconnect acceleration, and I'm going to right click it and promote it to variable, and what I will call it is just acceleration. So basically with our acceleration, what this is doing essentially is how it gets us up to speed basically with our character's ground speed. So I'm going to show you where acceleration is being gotten from, or retrieved from, I guess, for, you know, my English. But let's go into our content, third person and blueprints, and third person blueprint. If we go into character movement component, you'll see right here max acceleration, right? But let's actually look for acceleration. So you'll see that this is the general setup. It should have acceleration, or maybe I'm forgetting something, but basically it feeds off of max accelerations, because what happens, as you can see right here, is that the max acceleration is the rate of change of velocity. So when we are moving, what we're trying to do is as soon as we start walking or give a movement input, we are trying to reach max velocity. So if we do the get current velocity, it's going to consider a rate of change in velocity. So it's going to go from 0 up to 1500. So if we change this number to say 1200, right, then when we start playing and do, you know, we start moving, it's going to go from 0 to 120 or 1200. I don't know why I said 150 or whatever before, but 1500, 1200. And as far as the max acceleration. So when you do a print string, so for example, let me revert this back. I did not mean to keep it on the full value. So let me put it back to 1500 and compile that real quick. And let me show you the event tick for this. So if we do that and we grab our movement character, and then we do get current acceleration, and let's drag off of this and do a print string and put it in here. What's going to happen is when we start moving, and there's a reason there's an error because we didn't connect the acceleration or whatever to the other parts, so we're going to end up failing our animations, but don't worry about that. Hopefully you're not copying me and doing this. I'm just doing this because we're going to end up fixing it anyway. So I'm going to play an error editor, and you're going to see how we have zeros at the moment, but as soon as I move forward, you see how quick it went from 0 to 14,999, you know, to try to get to 1500, right? Or 1500. But then if I go left, you can see on the Y, we're going to 1500, you know, stuff like that. On the Z, there's nothing because Z involves doing other stuff. But as you can see, forward, our X is 1500 or negative 1500 because we're going the opposite way. This is 1500. Y is our 1500. Then this going the other way is negative 1500, stuff like that. So that's the thing it's trying to reach, is the 1500 for our max acceleration. However, we can kind of modify it to be slower, but you don't, I mean, it depends on your use case of why you would want to slow down acceleration or maybe put like a lower number. But for right now, we're just going to keep it as such and do this. And so what I'm going to do here, just to kind of make it simpler, because we want to do, I kind of want to turn it into a float. So what we're going to do is I'm going to get my movement component, and I'm going to do get max acceleration, and I'm going to put it here underneath that. And I'm going to then, I might have to drag it off a little bit more and move this down. And what I'm going to do here is I'm going to drag off of this and do a divide, and I'm going to drag the max acceleration off and put it into the division symbol. So what I'm trying to do, as I showed you earlier when we tried to do the get current acceleration, is that we are trying to get so we got the 1500 of whatever direction we're going. Now what we're doing with this by dividing it by the max acceleration is we're trying to check whether we have or don't have acceleration. So either a 0 or a 1 value. So with that being the case, what we need to do now, or at least do this just to make it a bit cleaner, I'm going to drag off here and do vector length XY, just so we can make it similar to ground speed, where we return like all the vectors into 1 basically, or at the XY into 1, and make it just a solid 1500. So I'm going to do that instead, and I'm going to convert that to a float and plug it in here. So that way it's better mathing, right? So off of here now, what I'm going to do is then connect that, and then you'll see that we basically got a simpler version of the 0, 0. But technically what I want to do is, let me undo that if it would stop tweaking out on me real quick, is I want to create a variable and call it has acceleration, just like that. And I'm going to connect this real quick, connect that there, and then move this down, and then boom, just like that. Because there's a reason why I also want this variable, and it's for certain things that we're about to do, right? Because I'm going to show you how to make the functions for our chooser table. So I got the basic setup now where I have, you know, a vector for acceleration, but now I have essentially a 0 or 1 value indication for having acceleration. So I'm going to compile and save this, and now let's go back into our is starting now that I've added the acceleration. So off of here, what I want to do is I want to grab the ground speed, because, you know, one of the things that we want to do is get the length of our velocity anyway, but since we have a ground speed as our base because we've already got the vector length, then we can just do this, and then off of it make a less than or equal to, and I'm going to say 20. And I'm going to explain why I gave 20 here in just a moment, because the next thing that I want to do, and let me move this up into here, is I want to grab my has acceleration, and I want to do a not equals 0 to keep it simple, and I'm going to then connect both of these into an AND boolean. And then I'm going to then return, so the output of the AND into the return node, and make sure that we have return value. So now what we're doing in here essentially is I'm getting the ground speed that was set in the reference, like how I explained earlier, and we're trying to see if it's less than or equal to 20. Because so the reason I gave 20 is because in the game animation sample project, as far as the float speed that they're using for their speed 2D, they're doing something similar to getting ground speed. They just call it speed 2D instead. But they have theirs set for, you know, less than or equal to 20 to indicate that, like, hey, we're still kind of in an idle-ish like state, stuff like that. So we want to play like, you know, either like a slight nudge or like a turn in place maybe, or like still kind of be idle so we're not like full blowing into something. And then here what I'm doing is I'm making sure that our acceleration is not equal to 0. Like, we have to have some form of acceleration. And so if both of these are true, it is then going to return true into our return node. So now that we got that, we're going to compile and save. And on our is starting, the second requirement that we need in order to put this function in our chooser table is making it a pure function. We have to make it a pure function, because if you keep it as an impure function, because of how they have execution pins or whatnot, it's not going to allow you to do that. So that is why we have to do pure. Now, the last requirement that we need to do is checking off thread safe. We want to enable this, and let me explain how to do a thread safe, right? So we have to set functions up like this in order to be able to check off threads safe, because what this is doing essentially with the thread safe checking is that what we're trying to ensure basically. Actually, let me pull up my definition I jotted down real quick. Where did I put it? Yeah, here we go. So like with what we're trying to do is ensure that actually, this is the wrong one. Let me pull up my other notes real quick, guys. I gotta search for it real quick. All right, guys, I'm back. So so regarding what thread safe is in Unreal Engine 5, the reason we are marking functions as thread safe is to make sure that that function can be safely executed in a multi-threaded environment without causing data corruption or unexpected behavior. This is crucial for performance optimization, and it also allows certain operations to run concurrently on multiple threads, improving the overall efficiency of your game. However, not all functions can be marked as thread safe. For example, functions that interact with the game world or rely on data that might be modified by other threads are typically not thread safe. So pure mathematical operations, on the other hand, are usually thread safe, just like this. Like, this is a pure mathematical operation. So I'll give you an example, right, of one that we won't be able to make thread safe. So let's do the isFalling, for example, right? So let me just make a new function and call it isFalling test, because we already have an isFalling boolean, so we can't do it. So say, for example, I drag off here and I get my return node, right? So off the return node, what I'm going to do is I'm going to go to update reference, and I'm just going to copy this at the moment. Or actually, what I'm going to do is do this instead, just get these two. And if I put them in here and I connect this return node, if I compile and save, everything looks fine, right? Like, cool. Well, now if I click on isFailing and do pure, it should be fine. We should be able to do that, just like you see here, because being a pure just means like you don't have execution pins. You can only return whatever is being done in here. However, now if we do a thread safe check and try to compile, we throw errors. So as you can see right here on get movement component, accessing an object reference is not thread safe, non-thread safe function is falling called from thread safe graph, et cetera, et cetera. And it's mainly because of how basically the movement function is coming off of our character movement, which is coming off of a character object reference, which is an interactable thing within the world and stuff like that. And stuff like that, like I mentioned earlier, is not thread safe. So that's why we can't do that. So that's why it purely needs to be a mathematical formula just like this in order for it to be thread safe. So now, just to show you, if I open up my content drawer and if I go back to characters, mannequins, animations, and let me just create a new folder called motion matching. And in here, let's just say you have all the stuff ready to do a chooser table and stuff like that. I'm going to assume you do. If not, I will be having a tutorial series on explaining your first 60 minutes with motion matching, where I discuss all of these. So assuming that you already have the required plugins, you would go ahead and do chooser table, and I'm going to call it CHT default, and then I'm going to open it up. So in my other videos, I've explained how to do a chooser table. So if you do want to get more involved with it, go ahead and look at my other videos just to see like how to do that. But the quick version of doing this is by going here to input context data and adding an element. And then in here, what we're going to grab is our context object type class and expand the index. And what we want to do off of here is grab our ABP Mani with this specific icon. Once we do that, we're going to change our direction to read write, just like that. And then our output would be pose search databases. So this one specifically with the pi icon, and then we're leaving object result. So now I'm going to go ahead and save this. So now if we go back into ABP Mani again, we have the isStarting function. It is a pure function as stated up here, and it is thread safe. So if we go back into here and add a column, because we're returning a Boolean value, I'm going to select a bool column. and when we click bind, you will now see ABP Manny, and now you will see is starting, and you'll see the is falling test because even though I compiled and saved and we errored out, because I got rid of this stuff and recompiled, it appears but nothing's gonna happen. But now you do see the is starting. So if we click on it and say like we added a row, now you can go between the different variables for it because we have stated a purely mathematical function and called it thread safe and a pure function, and it's going to treat it basically kind of like a Boolean now. So that's how you're going to want to do it. So, so let's do another one, for example, right? Let's do is moving, right? So if we go back into ABP Manny, and let's just say I do is moving. So off here, I would do a return node. And then off the is moving, I'm going to do pure and make it thread safe. And then here, what I'm going to do is I'm going to grab the ground speed and the has acceleration again. However, with the ground speed, I'm going to do differently this time. So technically, actually, what we can do here is I'm just going to copy these and remove these out of here because I'm just going to reuse them. The only thing I'm going to do differently is I'm going to change this node into a greater than node and then returning the value. So if our ground speed is greater than 20 and our acceleration is not 0, if both of these return true, then we are moving. So I'm going to compile and save, and now if we go back into the chooser table and do a new Boolean column, if we click bind ABP Manny, you will now see the is moving. So now let me show you, because you may be thinking, well, like, Silver, since we've been doing, these functions like this, what happens if you have the thread safe off, right? So if I do that, if I take thread safe off and do that, nothing bad's going to happen, but because it's not a thread safe function anymore, you could see that it no longer appears. So that's what I'm saying is you have to have it thread safe. But if we do thread safe and let's say we don't make it pure and I compile and save, then if we go back into here, you can see that we still do not have the is moving. So these are the requirements, is that it needs to be a function. For a function, it needs to be purely mathematical, it needs to be set to pure, and it needs to be thread safe. So if we compile and save again and go back to it, on our bind, you will now see that the is moving is back and it's choosable, right? So then lastly, let's do an is pivoting. This one I'm going to show you a very basic form of is pivoting, because I know a lot of people are like, especially with the GASP project, maybe want to make their own like pivoting function. So let me show you the very basic form of it, right? So let me go ahead and get rid of is falling test for the moment, and let's do is pivoting. So same thing that we did for the is moving and is starting. What we're going to do is drag off and do a return node, and we are going to make sure that is pivoting is pure and is thread safe. And I'm going to compile and save that real quick. So now what we're going to do, and this is going to be kind of weird, and I'm going to explain it as best as I can because I had to do some research on this myself to understand it. We are going to grab the acceleration and we are going to grab velocity. So that's another reason why I made a vector of velocity, even though we haven't used it in the previous two, but in here it's going to be a little bit different. So with our acceleration velocity, what we want to do is drag out and we want to normalize this. So this one specifically, because you should have a tolerance thing once you've done that. And I'm going to copy it and put it with the velocity as well. So we want the acceleration and the velocity to normalize. So essentially what this is doing, so let me find my notes real quick because I did have to note this down. So, well, the reason why we have it set to tolerance of 0001. So in Unreal Engine 5, the tolerance value in the normalize function helps avoid errors when normalizing vectors that are already very close to 0, which would make normalization impossible or result in a numerical instability. A tolerance of 0.0001 means that if the length of the vector is smaller than 0.001, the engine will treat it as a zero vector and avoid attempting to normalize it. So, when is this tolerance important? So, for small vectors, if a vector is very small, for example, its length is less than 0.0001, it could cause issues during normalization, as dividing by a very small number may result in inaccurate or undefined behavior. There's also things like general use. So for most game mechanics like movement and animation transitions, 0.0001 is a sufficiently small tolerance that avoids unnecessary issues while still being precise enough for gameplay purposes. So the default tolerance for normalization works well in most cases, including when you're calculating the dot product, which I'm about to get into, between normalized vectors. So if you don't find that the value doesn't work for you or for very specific animations, you can definitely adjust it. However, what we're trying to set is like a certain tolerance value where it's like, hey, don't kick in if below this tolerance. So now in saying that, what we're now going to grab is a dot node. And so I'm going to explain what a dot product is, and this one was kind of confusing as well. So here's basically how a dot works, and let me plug both of these in first. So I'm going to read out my notes in regards to this. So a dot product or a dot vector operation calculates the cosine of an angle between two vectors, returning a value between -1 and 1. So a value of 1 means that the vectors point in the same direction. So what that means is if we are accelerating and our velocity, like say for example we're going on the X with acceleration and velocity, if both of them are going in the same direction, then that will mean that this will return a value of 1. If we are going, say for example that if we're going left, right? So like if we're going forward with velocity, but then our acceleration just takes like a 90-degree turn, we end up with a value of 0 because we are not going directly against where we're going or our speed in like a forward direction. We're kind of going perpendicular. So it's close enough to like a same direction, but it's still opposing in a way where it just kind of offsets, because it's not like we're completely losing our momentum and stuff like that. It's just like we're continuing, it's just that we took a 90-degree turn. So however, let's just say that we are going forward with our velocity on the X or Y axis, but then all of a sudden we did a complete 180 with acceleration and decided to go the other way that we came. So if we were going forward on the Y and our acceleration, we decided to go backwards on the Y, well now we're going against our velocity, so we're opposing each other now, which results in a -1 value for our dot. So in order to get pivots, because what pivoting is doing is you're essentially going against your velocity or going in the other direction than where you were originally going. So if I was going forward and decided to just abruptly turn around and go backwards, I'm pivoting. So that's what we're trying to get with the dot product node, is to make sure that our acceleration is opposing our velocity or vice versa, and if they are, then we are pivoting, because then we get a -1 value. And don't worry, because I will be printing this out in a string so that we can kind of see what's happening. So now with the dot product, what we're trying to do here is we want to check if we are less than -0.5. And I'm going to show you why we're looking for that specific value to begin with. However, this can be modified to your preference. However, once I show you the print, you will then see what's going on. So what I'm going to do is copy this real quick, and I'm going to make a new function called pivot test. And I'm just going to drag these into here. I'm going to do a return node and put that in there. And then I'm also going to make this pure just so I don't have to hook up anything else. So if I go back into the event graph and I drag off of here and get a print string, and if I take out my pivot test and then connect it into here, and I compile and save, you can see that we're printing out 0.01 on the side, right? However, if we go forward, you'll see that we are at a 1. If I abruptly cuff left, you can see how if I do like 90-degree turns, that we're getting a 0 value, but like, you know, close to 1. But if I do like a rapid movement, we tend to hover around 0, right? However, now if I'm going, but then abruptly come back, you can quickly see how -1s have formed until we have fully turned around. So doing this, where I'm taking 90-degree turns, hover around 0. Going in a direction like this, or in a direction like this, just full on straight as a 1. But if I abruptly turn around, you can briefly see -1s pop up. So that is what the pivoting is doing. So what we're doing now is if our pivots are less than -0.5, because -1 is less than -0.5, we then return true. But then if it's greater than -0.5, then we are not pivoting, which typically you won't be like pivoting as far as like a normal action until you have to like abruptly turn around. So now that we have that, and you know, we have it as pure, we have it as thread safe, if we go into our chooser table and add another Boolean column because we turned it into a bool pure function, you will now see that we have a very basic is pivoting. So as you can see with our chooser table now, with what we have set up using mostly or as much as possible mathematical operations, we have a basic is starting Boolean function, we have a basic is moving function, we have a basic is pivoting function, and you can do a lot more with that. Like you can be very specific with like falling, jumping. So, you know, I'll give you an example for the jumping one kind of as like my last thing, right? So we can do is jumping, and let's just say that we get our velocity and we split the struct pins, because what we want is strictly the z velocity, because that's our up and down. And I say is greater than 100. Greater than 100, and then get my return node, and I plug it in there. So with that being said, with the 100, if my z velocity is greater than 100, then I am jumping, or I am jumping in the air. But what you may want to do is do greater than 0, or maybe just keep it at 100, because the other thing about it is if we copy this, right, and paste it down here, what you want to do for the falling as a very basic version is do less than. So what I'm actually going to do is convert this to greater than or equal to. But for the falling here, what we want to do is less than 100. And the reason I'm giving these as very basic scenarios, and I want to do a shout out to Cobra Code, because with his 2D projects that he's gone over, or tutorials that he's done, in one of his tutorial videos, this is how I've discovered how to switch paper flip books for 2D characters depending on whether they are jumping or if they're falling. So pretty much what you would do essentially is for the paper 2D sprites, you would say z velocity is less than 100, and then you would basically do a branch where it's like if true we're falling, if false we're jumping, because every other number. But when it comes to motion matching, you know, you're going to want to put specific values or find what works best for you, so that way you have your jump start, then you have your jump loop, and then you have your jump fall, right? So you have to figure out certain things for that. But then once you have that set up and done, then if we go into the add Boolean column, you can see that our is jumping is there. And then like I said, you can do an is falling, because this version of is falling, if we go back into here and we go to our update references, this is falling node just it captures any time we're in the air, basically just not on the ground. So that's why it doesn't help as much for capturing good motion matching jumps, is because you need to start being a bit more specific with where your jump start is, where your jump loop is, where your jump fall is, so stuff like that. So, but other than that, guys, hopefully that was educational for you. I'm hoping that you understood what was going on and my best explanation as possible for dot product, how to do the thread safe definitions, pure functions, stuff like that. So just to recap with them, what we did was we set these to its own function to update the references, because we need these set variables to constantly update. And then I've added acceleration for our get current acceleration, and then getting a 0 or 1 value to determine whether we have acceleration or not, stuff like that. And then we looked over pure functions, which basically are functions that don't have execution pins and cannot be modified. Or at least with what's inside the pure function, we don't want it to be modifiable, essentially. Like, you most certainly can have an input node, but then whatever happens like within here, and then returns out the value you're looking for. But in this case, what we did was we made a basic is starting, where our ground speed is less than or equal to a certain variable, and if we have acceleration, is moving, same thing. We utilize the same stuff, except we're checking to see if we are greater than a certain ground speed. For the is pivoting, we normalize the acceleration and velocity to ensure that we have above a certain tolerance, so that way our animations work properly and numbers are divisible, you know, as best they can be. And then the dot product is determining whether we are going against our velocity, if our acceleration is going against velocity or perpendicular to velocity, like if we take 90-degree turns, or if we're following the same path as our velocity using acceleration. So if we ever do abrupt turnarounds, then this kicks into a negative number, which then meets this threshold, which will then return that we are pivoting. So that's a very basic form of like checking whether or not we are pivoting. And then once we had all those functions, then you could see that after initializing our context data, setting up the type class, making sure we're APP Manny, stuff like that, we were then able to then apply our pure functions into the chooser table. So other than that, guys, if you have your own chooser tables and you have your own calculations and stuff that are being done and stuff like that, this has hopefully been an educational tutorial video on how you can then turn them into pure thread safe functions to then call them in your chooser tables. So I know it was a long drawn out video, but I had to go through as much explanation and examples as possible in order to not completely throw you off. So if you definitely have any questions or concerns about it, please post a comment and I will do my best, or maybe a veteran that could be passing by on the video could also answer that question so you can get as much help as possible. So other than that, guys, hopefully you enjoyed the video. If you did, please check out my other ones as well as my future videos to come. But other than that, guys, y'all have a great rest of your day and y'all take care.